Hey guys, here's a better lecture on matrix arithmetic. In this video, we're just going to be going over addition and multiplication. So to start, we will be looking at addition. And addition is the easier of the two. The only requirement we're going to be looking at is that we want the matrices to be the same size. So if we want to add these together here, we need these to be equal. So say this has 2 rows, or let's do this. 2 rows times 3 columns. And let me just put a little note over here. Okay. And then this is also going to need to be 2 times 3. So again, let's kind of look at this. We have 2 rows here, and there's no values in there yet, but we have 2 rows here as well, and then 3 columns and 3 columns. And then what this is going to create is another 2 by 3. So all the dimensions are going to be the same. They have to be the same to work. And when I show you an example, you will see why. So this is going to create, see, we have a 2 by 2 and a 2 by 2. So since all the dimensions need to be the same, we'll have a 2 by 2 over here as well. And then addition is exactly how you think it would be. We're going to look at, if we want to find the value that goes here in the first row and first column, we'll look at those same positions on either matrix. So we have 1 and 4, which is 5. We just add them together. 1 plus 4 is 5. And then if we want to find this value in the first row, second column, we'll do the same on the others. And we will add those values together. So we have 0 plus 5, which is also 5. And then you can see that if we're looking for this value here, it'll just be 2 plus 7, which is 9. And then the final value will be a 6. It's pretty simple. There's not much to worry about other than the fact that they need to be the same. And if you can see, like, maybe if we extended this out a little bit, got rid of this, and we added an extra row. If we wanted to add these together, we would need to be using this value, but you can see this value doesn't exist because this matrix is too small. So it's pretty intuitive that this will not work. One thing to keep in mind is these can swap and you'll get the same answer. And that might seem pretty basic, but you'll see in a moment that it's not the same with multiplication, which differs from like multiplying integers or something. So now looking at multiplication, the requirement is going to be slightly different. So we need, let's say this is a 3 by 3, and we're multiplying by, let's say 3 by 2 or something. So the one thing that we're going to be looking for is that the columns are the same as the rows on the second matrix. So the first matrix has 3 columns, and the second matrix needs to have 3 rows. So as long as these two values are the same, you can go ahead and multiply these matrices. So basically, I think the easiest way to kind of see if they work is writing out their dimensions like this and just making sure that these two closest values equal. And then one thing that we can note is the size of the matrix that we're going to be making is going to be these two values. So we're going to make a 3 by 2. So this matrix is going to be a 3 by 2, 3 rows and 2 columns. So whatever these values are, let's say we make like a 5 by 4 multiplied by a 4 times 2. is going to make, so say these are matrices that we're multiplying. This is going to create, you can see that this works because 4 is equal to 4, so, and then the size is going to be 5 by 2. So if we start with an example, it's not going to be quite as intuitive as the previous example. So let's just start with a 2 by 2 multiplied by another 2 by 2. And you can see, once again, this is valid because the number of columns is the same number of rows. On the columns on the first matrix is same as the rows on the second matrix. And the size is going to be these two values. So you can see this is just 2 by 2 multiplied by 2 by 2 gives you 2 by 2. So what we're going to see, let's add some values in here first. Okay, so now we have values in here. So what we're going to do is when we're finding a specific value here, see we have these four values, we're going to find the position of the value we're looking for, which in this case is going to be 1, 1, or first row, first column. And on the first matrix, we're going to be worrying about the rows. And on the second one, we'll be looking at the columns. So once again, if we're looking for row 1, column 1, we're going to be looking at row 1, column 1. And what we're going to do is we're going to start at their first values and then move to the right and move down as we go. And that's why the number of columns needs to be equal to the number of rows, because you'll see in a second. So if we start with 2 times 0, let's just write that down. So we have 2 times 0, and then we're going to add the next value. So we're going to move 1 to the right and 1 down, which is 3 and 6. So we're going to add 3 times 6. And then this, whatever this equals, is going to be 18 plus 0, which is just 18, goes in that spot that we were looking for. So now if, say, we're looking for the first row, second column value, we're going to be looking at the first row and second column of these matrices. So once again, we'll start with 2, but this time we're going to start with 1 on the other side. So we'll have 2 times 1. And then we're going to add 3 times 2. I got that just by moving over 1 to the right and 1 down. And then you can see that these are going to equal 2 plus 6, which is 8. So 8 goes there. And then this value is going to be second row, first column. So we're going to be looking at the second row, first column. And by now, this should make a little bit of sense. We're going to see 4 times 0 is 0. And 1 times 6 is 6. So 6 goes there. And then finally, our last spot, row 2, column 2, row 2, column 2. We have 4 plus 2, because 4 times 1 is 4, 2 times 1 is 2. So that gives us 6. So this definitely takes much more time than addition. It is a little more tedious, but that is how it's done. So say let's look at why we need the columns equal to the rows. So if I just extend this out a little larger and add, let's say 1 and 4, when we're looking for, say, this value, see, we're going to start with 2 and 0, move over right and down 1, and we're going to get 3 and 6. And then over right 1 and down 1, we get 1, and we run out of bounds here. So that's why they need to be the same. Which isn't quite as intuitive, like I said, as addition, but it will make sense after a few practice problems. One thing to keep in mind is if you swap these, you will not get the same answer. I'm not gonna show it in this video, but if you have a set of practice problems, I am sure that one of them will kind of display this in some way, where they'll have you solve it in one order and swap it, and then you'll kind of see that you get a different answer, which isn't like you think it would be, just because we're so used to integer multiplication, like 5 times 2 is 10, and 2 times 5 is still 10, but that is not the case for matrices. So that is going to be kind of the basics of everything here. Yeah, thanks for watching. Bye-bye.